This is the Dirichlet energy functional, and this is the strong problem of the. This is the Poisson equation in strong form, and u becomes 0 at the boundary. The weak solution of this problem is a minimizer to this linear functional. We will use this Dirichlet energy functional, go from this form to the variational formulation of the Poisson equation. We write j of u plus epsilon phi equals 1 divided by 2 grad of u plus epsilon phi squared d omega minus the integral over omega f times u plus epsilon phi d omega. This is grad u squared plus 2 grad u epsilon grad phi plus epsilon squared grad phi squared d omega minus the integral over omega f of u d omega minus epsilon omega f times phi d omega. We go to the next page. So we have that the functional u plus epsilon phi equals 1 divided by 2 integral over omega grad u squared plus 2 epsilon grad u grad phi plus grad phi squared d omega minus the integral over omega f of u d omega minus epsilon integral over omega f times phi d omega. How we can write this? 1 divided by 2 integral over omega. We split this integral here. We collect this term and this term here. So these two terms, we collect them. There is a reason why, and you see in a while. This one and this one. So we put these terms together, plus epsilon integral over omega grad u grad phi plus 1 divided by 2 epsilon squared grad phi squared d omega minus epsilon integral over omega f times phi d omega. This bit here is the Dirichlet energy functional J of U. And I just put here the rest of the terms. I take this term to the left-hand side. And at the right-hand side, I have this epsilon. I can take epsilon to be the common factor. Plus 1 divided by 2 epsilon squared integral over omega grad phi squared d omega. Now let's take the limit of epsilon going to 0 of j of u plus epsilon phi minus j of u divided by epsilon. This one is similar to the definition, to the rigorous definition of the derivative using the limit. So we take this is j prime at 0. We take this limit, and this can be evaluated easily. We have epsilon over epsilon integral omega grad u grad phi d omega minus the integral over omega f times phi d omega plus the limit of epsilon going to 0. I can write the limit as the sum of two limits. 1 divided by 2 epsilon squared over epsilon integral over omega grad phi squared d omega. This goes to 0, so this term vanishes, and I only end up that j prime of u of 0, j prime of 0 equals the integral over omega grad u grad phi d omega minus the integral over omega f times phi d omega equal to 0. From here, I have at the left-hand side the bilinear form. And at the right-hand side, I have the linear functional. The linear functional of f and this is the weak formulation for the Poisson equation. So what I have seen in this video is that I can go from the Dirichlet energy functional to the weak formulation. The weak solution of this problem minimizes this functional, and from this functional, by taking appropriate steps, I can obtain the variational formulation for the Poisson problem. And the function u belongs to the classical H1 Sobolev space, and the function phi is the test function belonging to H0 1 of omega, so which means that the function phi vanishes at the boundary, and it belongs to L2, and its gradient also belongs to L2.